So in this video, we are on page 8, and I am actually going to be showing you guys what to do when you have an equation where there's a variable on both sides. And I plan on showing you guys how to solve the exact same equation 4 times. We're going to actually look at method A, B, C, and D, and it's going to end up being the exact same equation that we solved 4 times in a row. And it's because there's a variety of ways to actually do this, and I'm actually going to promote method D here. It'll be the last thing I show you guys. Now, the first thing is to build your confidence a little bit to get you to realize that you'll actually be able to do this mentally in your head. So first, I want you to think about the fact that we have 1, 2, 3, 4, 5, 6, 7. There's 7 gold coins on this side of the scale, plus there's some in a bag. We don't know how many are in the bag. Now, on the other side of the scale, we have 2 of the bags. Again, we have coins in the bags. And we have 1, 2, 3, 4 coins not in the bag. So the first thing I want you to do is just kind of mentally think about how many coins must be in each bag if the 2 sides of the scale are completely balanced. So there's a variety of things that you're currently doing right now. One thing that a lot of students will do is say, okay, I'm going to take this bag and I'm going to take it off the scale. Now, that means that this side got a lot lighter, so then this side would come down and be too heavy. So to keep the balance, we would take this bag off the scale. And now basically we would have just the 7 coins over here. So let me just kind of X that out and X that out. And we have that 7 coins weighs the same as these 4 coins with 1 bag. So now if you have 7 coins over here and 4 coins plus the bag, which we don't know how many coins are in the bag, that's our unknown. Now what you can do is say, okay, let me take these 4 coins off the scale. And to keep it balanced, I'm going to take away 4 coins from this side. That means that these 3 coins that are left over would weigh the same as this 1 bag. So 1 bag has 3 coins. Now I've definitely drawn all over this, so let me just erase and kind of just mention again that all we said was if you take away this bag, you're going to take away this bag, so you take away a bag on each side. Then we took away these 4 coins and these 4 coins off. So what we have left then is this 1 bag weighing the same as these 3 coins. So 1 bag has 3 coins in it. Another way you could have thought about this was to start with the coins and to say, okay, let me get rid of all the coins on this side first. So 4 coins are gone. 4 coins are gone. Now when the 4 coins are gone, we still have 1 bag with these 3 coins and 2 bags over here. So the next thing you could do then is to say, let me get rid of this bag and let me get rid of this bag. And now I've got this 1 bag left, would weigh the same as these 3 coins. And again, we get 3 coins. So now let me show you guys the algebra behind this. And what I have in red is the X for the unknown amount of coins in the bag. And on this side of the scale, we have 1 bag with an unknown amount of coins in it, plus 7 coins that we can see. And over here, we have 2 bags of coins. We don't know how many coins are in each bag. And there are 4 coins on the outside. So the first thing that most of us think to do when we see this is to remove the bag that's on both sides. We got rid of this bag and we got rid of this bag. And that meant we only had 1 bag left on this side. When we get rid of this bag, we have only the 7 coins left on this side. So then the next thing we would do is subtract these 4 coins from this side over here. And then that means everything is off of this side except for just this 1 bag, and that's the X over here. And then we have the 7 coins. If we remove 4 of them, we'd have the 3 coins left on this side. So algebraically, when you have a variable on both sides, what we're seeing here is that you're going to be adding or subtracting the X's from each side. Now I'm going to move down here and I'm going to kind of start to show you guys how this all works. I do want you taking notes on method A, B, C, and D with me. I would like you to take notes on all of the methods. And for method A, we're going to start first by moving the constant to the right-hand side. Here's what I mean. We currently have a variable and a coefficient, and then a constant of 3, a variable with a coefficient, and a constant of -9. So what you're used to doing is starting with a constant, and you're very used to the constant being over here. So a lot of you, your gut reaction is going to be to -3 on both sides. And when you minus 3 on both sides, it'll cancel out over here, and we're left with 5f. Now on this side, when you subtract 3 from negative 9, we get a negative 12. And I'm bringing down this 2f. Now this is why method A I'm actually going to advise against. Because right here, we still have variables on both sides of the equal sign. And that's very, very, very unfamiliar for you guys. But up top, just like I showed that you can subtract an x from both sides and it can cancel out the variables, here's what we're going to do now. If the constant went to this side, notice that I'm now moving the variables over to this side. And that's why I'm choosing to cancel them out over here. I'm going to subtract the 2f's and it cancels out. And I bring my negative 12 down. Now 5f minus 2f is my 3f's. And I have 3f equals 12, equals negative 12. Now I'm going to divide both sides by 3, and negative 12 divided by 3 gets us that f would be a negative 4. All right? So what I'm going to do, I think sometimes with the work already being done for you, it's a little tough. So I'm just going to model real quick again, method A. If you start by subtracting 3 on this side, if you subtract the 3 from the constant, we'd get that 5f over here equals 2f minus 12. Now we're going to subtract the 2f on this side for it to cancel out over here. We get 3f equals negative 12. And then when we divide by 3, we get the negative 4. F would be negative 4. Now I'm also going to review how to check this with you guys right now in the video. And we're now going to be plugging in a negative 4 where we have f on both sides. Now, when we multiply a 5 times a negative 4, we get a negative 20. And then when we add 3 to that, we get a negative 17. Over here, 2 times negative 4 is negative 8, minus 9 is negative 17. So with the check step here, y'all, you don't know going into it what number to expect. Like, I don't have like equals 18 up here for y'all. Like if I had a, let me do 3x minus 6. If I had that equation, when you guys solved it, when you plugged it into check, you know you're expecting an 18 to know you're right, okay? What I'm saying down here is when you plug in the negative 4, you don't know what the total is supposed to be, but you know you're right if when you plugged it in on this side, the answer that you get is the same as the answer that you get when you plug it in on this side, okay? So all I'm doing here was showing you method A, but now I'm actually going to show you guys method B. All right, now the check step would still be the same because theoretically we're still going to get the same answer. But method B now says, let's move the constant to the left. So that means I'm now focusing over here with the negative 9. I'm going to add 9 to both sides. That cancels out over here. And I'm still advising against this method because you'll see that you still get a variable on both sides in this step. And that part's really, really, really unfamiliar. But since we moved the constant over here, now I need to get rid of the variable on this side and I need to swing it over here. So I'm going to do the opposite of 5f and subtract 5f's. That cancels out here and we get 12 equals, and over here it's negative 3f. And when we divide both sides here by the negative 3, we still get the same answer of f equaling the negative 4. Okay? So again, I'm advising against method A and B because right here in this line of work, you still have a variable on both sides, and that looks really, really, really unfamiliar. So what I'm going to show you guys now is method C. I'm now explaining here the work for method C. And notice that now with these methods, we're not paying attention to the constant anymore. We're actually paying attention to the coefficient. All right? So now I'm going to start with the coefficient. And between 5 and 2, if 5 is the bigger coefficient, I could start by subtracting 5f's on both sides. Now just stick with me as I demonstrate. So that would cancel out over here. We have 3 equals. And on this side, 2f's minus 5f's would be negative 3f's. And over here, it's a minus 9. Now this equation looks very familiar and you would then see that you add 9 and add 9 over here. We get 12 on this side equals negative 3f. And then our last step, when we divide by the negative 3, we get a negative 4 equals f. So same thing. Once again, we're still getting the same answer. But let me point out now why I'm advising against method C. Y'all, if this was an inequalities problem, if it was an inequalities problem, if this was an inequalities problem, right here, when we do the 2f minus 5f, we get a negative 3f. And that means in our last step, we have to divide both sides by a negative, which means you'd have to remember to flip the symbol if this were an inequalities problem. So when you start here with the bigger number, 5, and then you subtract it from 2, that's going to give you a negative coefficient, which sets you up to have to remember to flip the symbol. So method C here sets you up to have a negative coefficient, which means you then have to remember to flip the symbol. And because we forget to do that a lot, I'm going to advise against method C. And finally, now here I am getting ready to show you guys method D. Okay? Method D says we are going to start now by moving the smallest coefficient. Okay? So, whoops, sorry, I went the wrong way. So between the coefficients here, we have, again, 5 is a coefficient and 2 is a coefficient. The way you're basically going to handle all of these problems is to ask yourself which one is smaller. So 2 is smaller than 5, so we're going to start now by doing the opposite with this 2f. And you're going to see now when you subtract, we get a positive 3 with this f, which means we won't have to worry about flipping the symbol in the inequalities unit. So the f's canceled out over here, and now I have 3f plus 3 on this side, and then I'm just going to bring down my negative 9. All right, so now you have a two-step equation left to solve. We're going to get rid of this 3 by subtracting 3 on both sides. That cancels out over here, and we have a 3f equals negative 12. And then when we divide by this 3 and divide by this 3, we get f equals negative 4. And this is the method that I'm going to suggest. Okay? So back in your packets here, I'm just going to kind of go back. I'm going to erase all this ink. And again, I'm just going to kind of summarize now that you really have 4 different ways to solve these equations. And I'm going to promote method D down here. When you have an equation that has 2 terms here and 2 terms here, my strong suggestion is going to be to ask yourself which one is the smaller coefficient. Since 2 is smaller than 5, we're going to subtract 2f's on both sides and it cancels out over here, and I bring down the negative 9. 5f's minus 2f's would be 3f's, and then I just bring down the 3. Now this is a very familiar two-step equation. Our constant is 3, so I'm going to subtract on both sides. Negative 9 minus 3 is negative 12, and now I'm going to divide both sides by this coefficient for it to cancel out. And we get our negative 4. Notice now to check, I'm plugging in the negative 4 on both sides. And when I simplify, over here I get a negative 17. Over here I get a negative 17. And since I got the same thing on both sides, I know I'm right. And that concludes the video for how to solve an equation with a variable on both sides for page 8. Thank you.